In this problem, we are given a data table containing the ages of mothers that are giving birth to twins. In the second column, we have the frequency of twin births, that is, how many twin births occur in each age group. Now, part A asks, for each age class, find the relative frequency. To calculate the relative frequency, we'll need to do a little bit of math in Excel. Let's remind ourselves of how to calculate relative frequency. Relative frequency is equal to the following. We take the frequency divided by the total, and we'll do this for each of the rows. So first, we'll need to find out what the total is. To do this, we'll make an additional row below the 40 to 44 age group and type total. Next to this, we'll say equals SUM, or sum, and we're going to add up all of the frequencies above. So equals SUM, parentheses, and then select all of the frequencies above, starting from B2 going to B7. When we press enter, we see that the total number of births is 358. Now remember, this 358 is always going to be our total for all the way through the problem. I'm going to paint it gold using the paint bucket in the font menu. And let's remind ourselves that this total is a constant. And when you have a constant, we need to press F4 on top of it. Let's try it now. We'll go over to the relative frequency. We'll say equals, click on the 5, and divide by the total at the bottom. So we're taking the frequency in row 2, that's 5, divide by the total at the bottom, 358. But the total is a constant, so we'll now press the F4 key on our keyboard to add the dollar signs before and after the B. When we press enter, this will give us the relative frequency for row 2, and now we can use the black cross and select the little knob on the bottom right-hand corner of the box. This will calculate the relative frequencies for each of our age groups. Now, if we would like to reduce the number of decimal places, we can click Home and go to Decrease Decimal, which is the button on the right side of the number section here. 3 decimal places should be enough. So here we have our relative frequencies, and that is the answer for part A. Part B asks, based on this table, what can you conclude about the relationship between age and the probability of having twins? For this, it may be useful to make a graph to visualize this. So I'm going to select the frequency and go to Insert, and then go to the Chart section. The Chart section is located here, and we will need a bar graph to display this. Let's give it a proper title. We'll call this Frequency of Twin Births. Let's also add some axis titles by clicking the green plus sign next to the graph and selecting axis titles. On the y-axis, up and down, that's the frequency. That will always be the frequency. And on the bottom, we'll type the age of the mother, because that's what the frequency is classified under. Now we'll make an edit to the data labels here as well. We want these not to say 1, 2, 3, 4, 5, and 6, but rather 15 to 19, 20 to 24, 25 to 29, and so on. So we'll right-click on these numbers, and we'll say Select Data. And we will say Edit on the right side, and now we select the ages. When we press OK twice, now we see that the ages are listed under the frequencies correctly. So we can see that we're more likely to have twins at 25 to 29 and 30 to 34, and less likely at 15 to 19, or 35 to 39, or 40 to 44. Now for part C. Part C asks, when a set of twins is born, what is the probability the mother is in her 20s? Well, let's remind ourselves that that encompasses 2 groups in our histogram. If the mother is in her 20s, that's going to cover 20 to 24 and 25 to 29. Now what we'll do here is go to those 2 groups and add the relative frequencies. So let's make some space below our figure. Part C, we could say the probability of being in her 20s. We'll say that just equals the relative frequency in the 20 to 24 group, and add the relative frequency 25 to 29. Press enter, and this will be the probability of the woman being from 20 to 29. Part D is a similar question. It asks, when a set of twins is born, what is the probability that their mother is at least 20 years old? So let's remind ourselves of what that means. At least means 20 or higher. So it includes 20 and is everything higher. So we can tell that's going to be most of the groups we have. 20 to 24, 25 to 29, 30 to 34, 35 to 39, and 40 to 44. The only one missing is 15 to 19. So let's restate this down here at the bottom. The probability of being 20 or more is the same as the probability of being not 15 and 19. So what we can do, if we're ever trying to say not something, we can always take 1 minus the thing it's not. And you'll still get the same answer. So let's try this. We'll go over to this cell. We'll say equals 1 minus the only part that does not fit the description, 15 to 19. Make sure we click in the relative frequency, and we get 0.986. Now, if we wanted to, we could also just add up all of the relative frequencies between 20 and 44. Just to show that this works, I'll say equals all of the relative frequencies added together, except for 15 and 19. And when we press enter, we'll have 0.986. Just to show you the formula again, I'll click inside the cell. Once again, we can see all the boxes other than the 15 and 19 are being added together here. Now, part E asks which approach to probability are the values from parts C and D. Briefly explain. Now, they tell you in this question that they're asking about relative, classical, and subjective. Now, we can say our approach here is going to involve relative frequency. This was already given to us, but essentially we are looking at something that's already happened and analyzing it. Now, classical is slightly different. Now, in classical probability, we already know what should happen. In classical probability, we use that to make predictions. Now, for subjective probability, that's just gut instinct. We absolutely do not use that. We use almost always relative frequency and classical probability. Trying to go by gut instinct usually doesn't hold up well in an economic or scientific study.